KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Hello students, today we will start new chapter, that is applications of integrals. Okay. Before going to applications of integrals, in school level geometry, means up to 10th standard, we have learned different formulas to calculate areas of various geometric figures such as triangles, rectangles, squares, trapezium, circle. Okay, we learned all these formulas. Now these formulas are fundamental in the applications of mathematics in real life problems. These formulas are very useful to solve various real life problems of mathematics. Okay, but formula of elementary geometry allows us to calculate area of many simple figures. Okay, like area of rectangle, area of triangle, area of square, area of trapezium, okay, area of circle. These help us to solve, these formulas help us to solve many problems, many real life problems. Okay, but these formulas are inadequate for calculating area of enclosed figures. See, in real life, every figure may not be in circular shape, in square shape, in rectangle shape. Okay, it can be different curves. Okay, now these formulas are not sufficient to calculate areas of such figures. Okay, to solve these kind of problems, we need concepts of integration. We need concept of integration. Okay, in earlier chapter, what chapter we learned? Integrals. In integrals, we have a specific topic that is called definite integral. Okay, in definite integral, limit as a sum we discussed. Okay, what is the limit of a sum? The limit of a sum, it gives area of the curve y is equal to f of x between the coordinates x is equal to a and x is equal to b and x axis. Okay, area of the curve, algebraic sum of the areas, algebraic sum of the areas between the coordinate x is equal to a, x equal to b and x axis. Okay, here in this chapter we will study specific applications of integrals to find out area under simple curves. Okay, area under simple curves such as area between the lines, area by the curve between x is equal to a, x is equal to b. Okay, between the area between the line and circle, area between two circles, area between line and parabola, area between parabola and ellipse. Okay, we'll solve different types of questions. Okay, now first of all, area under the curve. Okay, area under simple curves we'll discuss. Okay, area under simple curve, suppose if you consider something like this, if we have y is equal to f of x, okay, this is the curve y is equal to f of x, and we have to find area between the lines x is equal to a and x is equal to b. Okay, now using definite integrals, how we can find area? Area, how we can find as a limit of a sum? We will divide the curve in stripes. Okay, we will draw vertical stripes. Okay, so many vertical stripes. Now here, now this is one vertical stripe. Okay, here with a width of dx. Now I will consider this as a rectangle. So area of this stripe is what? Y dx, okay? Length is y and width is dx, y dx, okay? Now as number of stripes are increasing, okay? Now if you take like this, if you take like this stripes, okay? Now if you calculate area, it is not exact area, that may be approximate area. By introducing infinite number of stripes, what will happen? This dx approaches to 0, width approaches to 0, then the area what you calculate, that is almost equal to the original area, okay? Means when a curve y is equal to f of x given and x limit a and b given, okay, area under the curve y is equal to f of x between the limits x is equal to a and x is equal to b is given by integral a to b y dx or integral a to b f of x dx, provided graph is entirely above x axis. Graph is entirely above x axis. If a graph of the curve between the lines x is equal to a, x equal to b is completely lies above x axis, area under the curve is integral a to b y dx. Here we will consider stripes like this with a length of y and a width of dx, okay? Area of this rectangle is y dx. By introducing infinite number of stripes and adding all those areas, that all those sum of the areas is equal to area, original area. So that is given by integral a to b y dx or integral a to b f of x dx, okay? Area of the region p q r s p, this area is integral a to b y dx or integral a to b f of x dx, okay? Here simple curve might is simple curve y equal to f of x is complete lies above x axis between the limits x is equal to a and x is equal to b, okay? Now similarly, instead of using x limits, suppose y limits given, okay? Y limits given, okay? Now we have something like this graph, y limits given, y equal to c and y equal to d. Between these two limits, area by the curve, area bounded by the curve, x is equal to g of y. In earlier case y is equal to some function of x, here x is equal to some function of y, okay? Area bounded by the curve x is equal to g of y between the limits y is equal to c and y is equal to d is integral c to d x dy. Here what we will consider is, here we will consider horizontal stripes. In this case we will consider vertical stripes, okay? Length as y and width as dx, y dx. By introducing so many stripes, infinite stripes, area becomes integral a to b y dx. Now here by considering horizontal stripes with a width of dy, area of each rectangle is x dy, okay? As number of stripes are increasing, number of horizontal stripes are increasing, okay? Sum of these areas almost is equal to required original area. So area bounded by the curve x is equal to g of y between the limits y is equal to c and y is equal to d and the curve x is equal to g of y is given by integral c to d x dy or integral c to d g of y dy, okay? Now here we consider horizontal stripes, okay? Now in this case, first case function is given as in terms of x, y is equal to in terms of x. Now in this case function is given x is equal to some function of y, here first case y is equal to f of x, y is equal to some function of x and x limits given as a to b, okay? In second case function is given as x is equal to some function of y, x is equal to some sin y, x is equal to sin inverse of y, something like this it is given, okay? And limits y is equal to c to y is equal to d given. So in such case area bounded by the curve is area is equal to integral c to d x dy, or else integral c to d g of y dy. Now in first case we consider vertical stripes, in second case we will consider horizontal stripes. Curve y is equal to f of x is below x axis between the limits x is equal to a and x is equal to b. The position of the curve under consideration is below x axis, that is f of x is negative between the lines x is equal to a and x is equal to b. Okay, between the limits x is equal to a and x is equal to b. Then the area bounded by the curve x axis and the coordinates x is equal to a and x is equal to b is negative. What will happen? Suppose you have curve something like this, y is equal to f of x. Okay, now between x is equal to a and x is equal to b, this curve is negative. This curve is negative. Okay, f of x is less than 0 between x is equal to a and x is equal to b. Now what will happen? In such case, integral a to b f of x dx is negative. Integral a to b f of x dx is negative. Definite integration is negative. But area means area has to be positive value. So in such case, we will take the absolute value. We'll take absolute value. Suppose you got this area between x is equal to a and x is equal to b, and y is equal to f of x as some minus 5, for example. Okay, in such case we'll take its absolute value. Absolute value means its magnitude only will take. Magnitude means simply you take modulus of that quantity. Now when graph is completely above x axis, you will get area as positive. Okay, when graph is completely above x axis, like in first case, when graph is completely above x axis, area value is positive. Suppose graph is completely below x axis. Area is what? Negative. In such case, we will take its absolute value. Area is equal to its absolute value, nothing but modulus value will take. Okay. Now for example, if you get y is equal to f of x between x is equal to a and x is equal to b, area as minus 5. In such case, what we will do? Modulus of minus 5, nothing but plus 5. Okay. Now if the position of the curve under consideration is below x axis, that is f of x is negative between the limits x is equal to a and x is equal to b. Okay. The area bounded by the curve x axis and the coordinates x is equal to a and x is equal to b is negative. Okay. Whenever if area is negative, we take its absolute value. Area cannot be negative, so we will take its absolute value. Okay. So what we will consider, suppose if you have graph something like this, okay, y is equal to f of x between x is equal to a and x is equal to b. Okay. Now here in this region function is negative, so area is negative. In such case we will take its modulus. That is modulus integral a to b f of x dx. But this is the main difference between definite integral and area under the curve, application of integral. In case of definite integral, that is algebraic sum of areas. Algebraic sum of areas means plus means plus, minus means minus. Okay. In case of applications of integral, area means we will take absolute value. Suppose it is negative, we will take its positive value. Okay, we will take its absolute value. Now suppose in case of definite integral, find integral something, okay, a to b f of x dx. If you get it as minus 5, definite integral we will write it as minus 5. Suppose question is to find the area between x is equal to a, x is equal to b and f of x. Suppose if you get that value as minus 5, we will write its absolute value, that is plus 5. Okay. Now suppose between x is equal to a and x is equal to b, some part of the graph is negative, some part of the graph is positive. Something like this if we have, okay. Suppose x is equal to a to x is equal to b, we are finding area. Okay. Suppose a to c area is negative and c to b area is positive. Okay. A to c area is negative and c to b area is positive. Okay, means you are finding area between the lines x is equal to and x is equal to b for the function y is equal to f of x. Okay, but in between x is equal to a to x is equal to c, function is negative, and x is equal to c to x is equal to b, function is positive. So what we will do is we will calculate area like this, integral a to c y equal to f of x dx, but we will take its modulus. Okay, modulus will take, because this area is negative, so to take absolute value we will take modulus. So suppose this is a1, this is a2, area A is equal to modulus of a1 plus a2, because c2b area is positive, above x axis, that is positive. Okay, that is what it is written, here a1 is less than 0 and a2 is greater than 0. Area bounded by the curve y is equal to f of x, x axis, and the coordinate x is equal to and x is equal to b is given by area is equal to modulus of a1 plus a2, modulus of a1 plus a2. Okay, now here we discussed few curves. Suppose curve is completely above x axis, between the limits x is equal to a and x is equal to b, its area is integral a to b y dx or integral a to b f of x dx. Okay, suppose curve is given as x is equal to g of y form and y limits given. In such case, area is equal to integral c2d x dy or integral c2d g of y dy. Okay, now if curve is completely below x axis, now what will take? Okay, if curve is completely below x axis from the limits x is equal to a to x is equal to b, in such case area is equal to modulus of integral a to b f of x dx. Okay, now suppose if some part of the curve is below x axis and some part of the curve is above x axis, what we will do? Whichever below x axis, for that region we will take modulus, and whichever part is above x axis we will take that area as it is. Now here, as it is given in the example, suppose a1 is below x axis, so we will consider this part as absolute value, modulus of a1. Now a2 is completely above x axis, so this part as it is a2. So area is equal to modulus of a1 plus a2. Okay, now we will discuss some problems on this concept. First question, example 1, find the area enclosed by the circle x square plus y square is equal to a square. X square plus y square is equal to a square. My area of a circle whose center is origin and radius is a is pi a square, that formula we know. Okay, now we will prove that. Okay, we will find the area of the circle x square plus y square is equal to a square. Okay, now x square plus y square is equal to a square, curve like this, no, x square plus y square is equal to a square, center is 0 0 and radius is a units. Now where this curve intersect the coordinate axis, x axis at means x axis means y, if you put y 0, x square equal to a square means x is equal to plus or minus a. So intersect x axis at a comma 0, a dash minus a comma 0. Where this curve intersect y axis means x ordinate 0. If you take x 0, y square equal to a square, so y square equal to a square means y is equal to plus or minus a. So what we get? b 0 comma a, b dash 0 comma minus a. But to find out this area, what we will do is simply I'll find any one quadrant area, multiply with 4. Okay, the whole circle area is equal to 4 times of any quadrant of the circle. Okay, so that is what it is written here. Whole area is equal to 4 times area of the region AOBE. Okay, AOBA. Okay, now if you observe here in AOBA, now here what are the limits? X is equal to 0 to x is equal to a. Okay, x is equal to 0 to x is equal to a. Suppose if I want to use vertical stripes, x limits we have to take. So x is equal to 0 to x is equal to a. Okay, between the limits x is equal to 0 to x equal to a, and y dx we have to write. Okay, so area is equal to 4 times of integral 0 to a y dx. Okay, integral area is equal to 4 times of integral 0 to a y dx. Okay, here what is the curve given? X square plus y square is equal to a square. So y square is equal to what? A square minus x square. Y square is equal to a square minus x square. So y is equal to, if you take square root on both sides, y is equal to plus or minus square root of a square minus x square. Y is equal to plus or minus square root of a square minus x square. Now whatever area we consider here, what area, what region? AOBA area, that is nothing but first quadrant area. In first quadrant both x ordinate, y ordinate positive. So y is equal to plus or minus square root of a square minus x square. As you are considering first ordinate, so what we can write? Y is equal to square root of a square minus x square. So area is equal to how much formula now? Area is equal to 4 times of integral 0 to a square root of a square minus x square dx. Okay. But this formula, we have direct formula for this one. What is integral square root of a square minus x square dx is equal to x by 2 into square root of a square minus x square plus a square by 2 into sin inverse of x by a. Okay. Now lower limit is 0, upper limit is a. Now in integrals, we have a formula for integral square root of a square minus x square dx. What is that formula? X by 2 into square root of a square minus x square plus a square by 2 into sin inverse of x by a. Lower limit as 0, upper limit as a. Now by substituting upper limit in place of x, if we substitute a, so what we get? A by 2 into square root of a square minus a square. A square minus a square is 0. So a by 2 into 0 plus a square by 2 into sin inverse of a by a. Sin inverse of a by a is nothing but sin inverse of 1. Okay, minus lower limit in place of x, if we substitute 0, this part is 0 and sin inverse of 0 is also 0. Okay. So what we have then? This part is 0, a by 2 into 0 is 0. So a square by 2 into sin inverse of 1 is how much? Sin inverse of 1 is pi by 2. So 4 times of a square by 2 into pi by 2, 4 get cancelled. So area is equal to what? Pi a square. Pi a square. Now here what we did? To find out area of the circle, x square plus y square is equal to a square. Okay. Now you should know to draw rough diagrams of circle, parabola, ellipse, these basic things you have to know. Okay. Basic diagrams. Now this is the diagram. X square plus y square is equal to a square. Center is 0, 0 and radius is a units. So intersect x axis at a comma 0 minus a comma 0. Intersect y axis at 0 comma a, 0 comma minus a. To find out circle area, instead of finding all whole area, simply find out any one quadrant area, multiply with 4. Okay. For this what I am writing is whole area is equal to 4 times of area of the region AOBA. Okay. So here you can use y limits or x limits. Okay. You can use y limits or x limits. Now I will use x limits. So x limits from x is equal to 0 to x is equal to a. So lower limit is 0, upper limit is a. Y dx we have tried. So what is y? So as x square plus y square is equal to a square, y is equal to plus or minus square root of a square minus x square. Okay. Now as we are considering area in first quadrant, y ordinate is positive, so y is positive. So what we can write? Y is equal to square root of a square minus x square. So area is equal to 4 times of integral 0 to a square root of a square minus x square dx. So 4 into, we have the direct formula, integration formula for square root of a square minus x square, that is x by 2 into square root of a square minus x square plus a square by 2 into sin inverse of x by a. Lower limit as 0, upper limit as a. By substituting upper limit a, what we get? A by 2 into 0 plus a square by 2 into sin inverse of a by a, sin inverse of 1 minus lower limit 0, 0. Okay. So a square by 2 into sin inverse of 1 is pi by 2. So 4 get cancelled. We get a is equal to pi a square. Okay. Again same problem we can solve using x limit also, y limits also. Here we solve using x limits. Now by taking horizontal stripes, now what we can do? Integral 0 to a, y limit also 0 to a only, no? 0 to a x dy. So x dy, what we can write? X what we can write? So as x square plus y square is equal to a square, x square is equal to square root of x square is equal to a square minus y square. So x is equal to plus or minus square root of a square minus x square, a square minus y square. Similarly, what you wrote here, By using horizontal limits also we can write. Okay, simply in place of x we have y, in place of y we will have x. So what will get? X is equal to plus or minus square root of a square minus y square. X is equal to plus or minus square root of a square minus y square. As we are considering first quadrant, okay, we will consider as x as positive. So in such case a is equal to 4 times of integral 0 to a square root of a square minus y square into dy. Okay, as usual formula, by applying upper limit and lower limit we will get the same answer, area of the circle as pi a square. Okay, now we will continue remaining problems and other concepts in next session. Thank you.